For nearly 5 months, Voyager 1 was silent, not quiet. Silent in the most unsettling way imaginable. After more than 4 decades traveling farther than any human-made object in history, the spacecraft suddenly stopped speaking in a language we could understand. What it sent instead was chaos. Strings of zeros, meaningless numbers, fragments of data that looked less like telemetry and more like noise. At more than 14 billion miles from Earth, this wasn't just a technical glitch. This was the very real possibility that humanity's farthest explorer had finally been lost in the darkness. And yet, when engineers managed to bring Voyager 1 back to life, something didn't feel normal anymore. Because the data it resumed sending wasn't just about survival. It was about a boundary we thought we understood, and clearly didn't. What Voyager 1 detected at the edge of the solar system directly contradicted decades of scientific models. The environment was colder where it should be hotter, denser where it should be emptier, and structured in ways no one expected. It was as if the solar system didn't slowly fade into interstellar space, but instead slammed into it. And that discovery forces one unavoidable question. What else is hiding beyond the sun's final frontier? Voyager 1 wasn't designed to survive this long. Launched in the late 1970s during a once-in-a-lifetime planetary alignment, the mission was originally planned to last just a few years. 4 years to study Jupiter and Saturn, and then silence forever. Anything beyond that was a bonus. But Voyager refused to follow the plan. Decade after decade, it kept moving outward, deeper into regions no spacecraft had ever reached, until late 2025, when the impossible almost happened. Voyager 1 began transmitting data that made no sense. Its position reports were wrong. Its system readings were scrambled. It was still transmitting, but not coherently. Engineers soon realized the nightmare scenario. A portion of the spacecraft's flight data system memory had failed. This wasn't a broken sensor or a temporary glitch. This was corrupted code inside a computer that had been operating non-stop for more than 40 years in deep space, constantly bombarded by cosmic radiation. Fixing this wasn't like updating software on Earth. Every command sent to Voyager takes 22.5 hours to arrive and another 22.5 hours to hear back. Every attempt was a step into the unknown. One wrong move, and Voyager 1 would be gone forever. The engineers made a bold decision. They began relocating critical code into unused sections of memory, effectively performing brain surgery on a spacecraft billions of miles away. 2 days later, Voyager responded. Communication was restored. Humanity had pulled its farthest explorer back from the brink. But Voyager didn't come back unchanged. Long before the communication failure, Voyager 1 had already crossed into territory no one truly understood. Solar particles suddenly dropped. Galactic cosmic rays spiked. Voyager had crossed the heliopause, the boundary where the sun's influence ends and interstellar space begins. Scientists expected this transition to be gradual, like walking into a fog that slowly thickens. Instead, Voyager found a wall. The solar wind didn't fade away. It stopped, almost abruptly. On one side, particles from our sun flowed outward. On the other, interstellar plasma pressed inward. The solar system wasn't dissolving into space, it was colliding with it. Even stranger, Voyager detected that the plasma beyond the boundary was colder and denser than predicted, while the region just inside the boundary was hotter and less dense. The numbers were off by an order of magnitude. The energy was missing. The temperature didn't match. The density didn't behave. It was like discovering that the shoreline between ocean and land wasn't sand, but a moving wall of water frozen in place. And that wall wasn't stable. Massive waves, some stretching 10 astronomical units in size, rippled across the heliosphere's boundary. The edge of the solar system wasn't calm. It was alive, shifting, breathing, and reshaping itself in ways no model had predicted. As Voyager 1 continued deeper into interstellar space, it detected something even more unsettling. A persistent, steady signal. A low-frequency hum at around 3 kilohertz, remaining nearly unchanged for years. Space is supposed to be silent. Sound can't travel through a vacuum. But this wasn't sound as we hear it. This was plasma oscillations, electromagnetic waves converted into audio so humans could interpret them. What made the signal disturbing wasn't its existence, but its consistency. For nearly 3 years, The hum barely changed, even as Voyager traveled billions of miles farther from the sun. Some scientists believe it's the background vibration of interstellar plasma itself, the cosmic equivalent of hearing the ocean from deep underwater. Others quietly admit that its stability is hard to explain. Something, somewhere, is maintaining that energy. And Voyager isn't just listening, it's also speaking. Every signal it sends reaches Earth with a power equivalent to a whisper compared to a refrigerator light bulb, yet it still arrives, captured by giant antennas around the world, pieced together from noise, pulled out of the void. A conversation across 14 billion miles, barely holding together. Voyager 1 revealed that our solar system is not drifting freely through space. It is wrapped in a protective bubble, shaped and compressed by the interstellar medium. That bubble shields Earth from deadly cosmic radiation. It is, quite literally, part of the reason life here exists. Beyond that, Voyager showed that our sun sits inside a much larger structure known as the local bubble, a vast cavity carved by ancient supernova explosions. A quiet harbor in a violent galaxy, a region of space unusually empty, unusually calm. This means our view of the universe, our starry skies, even our history as a species, may be shaped by where we are in the galaxy right now. The solar system didn't just form here, it arrived here. Voyager 1 wasn't designed to answer questions about humanity's place in the universe. It was built to take pictures of planets. And yet, 40+ years later, it's doing exactly that. Not with images, but with data, with whispers, with impossible discoveries at the edge of everything we thought we knew. For decades, scientists believed the heliosphere was a gentle cocoon, a fading bubble where the sun's influence slowly dissolved into the galaxy. Voyager 1 destroyed that idea completely. What the spacecraft found was not a peaceful transition, but a collision zone. A cosmic traffic jam where solar plasma and interstellar plasma crash into each other head-on at unimaginable scales. At this boundary, particle density suddenly spikes, not because space becomes fuller, but because two invisible rivers collide and pile up. Imagine driving at full speed into a wall of fog, only to discover the fog pushes back. That is the heliopause. Solar wind flows outward until it hits interstellar pressure, then bends, folds, and redirects itself. Interstellar plasma does the same from the opposite side. Voyager detected that this boundary is constantly moving, rippling, and warping. Massive waves roll across it at strange angles, some stretching the distance between the Earth and the Sun 10 times over. This is not a static border. It breathes, it shifts, it reacts. And most disturbing of all, the physical properties here do not obey existing models. Temperatures are lower than expected. Densities are off by a factor of 10. Energy seems to vanish without explanation. Somewhere in this boundary layer, physics is doing something we do not yet understand. Voyager's discoveries do not stop at the heliopause. They force scientists to zoom out, far beyond the solar system itself, and confront a much larger realization. Our sun is not floating in average galactic space. It sits inside a gigantic cavity known as the local bubble, a structure roughly 1,000 light-years wide. This bubble was carved by a series of supernova explosions millions of years ago, each one blasting interstellar gas outward like shrapnel from a cosmic bomb. The result is a vast region of unusually empty space, surrounded by dense walls where new stars are forming. We are not in the middle of chaos. We are inside a quiet hollow, like dust settling inside a cosmic lung. Voyager's data supports this idea indirectly. The interstellar plasma it measures is colder and denser than expected, while the region near the sun is hotter and thinner. These are signatures of a system embedded inside a larger structure, protected not just by one bubble, but by two. This changes how we understand our visibility of the universe. If the space around us were denser, many stars would be hidden behind clouds of gas and dust. Our clear night sky may be a rare privilege, not a cosmic default. In other words, humanity didn't just evolve on the right planet, it evolved in the right neighborhood. Then there is the signal, the one that refuses to fade. Voyager 1 detected a steady, persistent hum deep in interstellar space, a plasma wave oscillation holding nearly the same frequency for years. In a universe defined by turbulence, randomness, and decay, consistency is suspicious. Plasma waves are not sound, but they can be translated into audio. When scientists did this, what they heard was eerie, a monotone vibration, stable across billions of miles, as if interstellar space itself had a heartbeat. Some researchers argue this hum is simply the background resonance of interstellar plasma, a natural vibration of the medium between stars. Others admit the explanation feels incomplete. Stability at that scale suggests a continuous energy source, something maintaining equilibrium in a region where chaos should dominate. Voyager did not move closer to the source, it moved away, and yet the signal barely changed. This does not mean intelligence, it does not mean intent, but it does mean interstellar space is not silent, not empty, and not passive. It is structured, dynamic, active. The void is not void at all. Voyager 1 is dying. Slowly, quietly, inevitably. Its power comes from radioactive generators that decay year by year. Instruments are being shut down one by one. Systems that have worked flawlessly since the 1970s are now surviving on borrowed time. Soon, Voyager will no longer be able to orient itself. Soon after that, it will no longer speak. The last signal will leave the spacecraft, travel for more than 22 hours, reach Earth, and then there will be nothing. But even in silence, Voyager continues its mission. It carries a message, a golden record etched with images, music, languages, and sounds of Earth. A bottle thrown into a cosmic ocean, not knowing if anyone will ever find it. Voyager is not just exploring space anymore, it is becoming part of it. Drifting through interstellar darkness, passing stars over tens of thousands of years, carrying proof that once, on a small pale blue dot, a species looked outward and dared to ask what lies beyond. Voyager 1 was never meant to answer questions this big. It was built to take pictures, measure particles, and send numbers back home. And yet, after more than 40 years, it has done something far greater. It has shown us where we truly are. At the edge of the solar system, Voyager did not find emptiness. It found structure. It did not find silence. It found a hum. It did not find a gentle fade into darkness, but a sharp boundary, a living frontier where forces collide, bend, and reshape each other. What makes this discovery impossible isn't that it contradicts one theory. It's that it contradicts our intuition. We imagine space as a gradual nothingness. Voyager revealed it as a layered reality, filled with invisible walls, moving waves, hidden pressures, and unseen interactions that quietly protect everything we've ever known. And then there is the irony. The farther Voyager travels from Earth, the more clearly it reflects us back to ourselves. That fragile heliosphere it crossed, the chaotic boundary it mapped, the cosmic bubbles it helped reveal, all of it explains why life here was even possible, why our planet was shielded, why our sky is clear, why our species had the time to look up and wonder. Voyager is now a relic from another era, powered by fading atoms, speaking in whispers so weak they can barely be heard across the void. Soon, it will fall silent forever. But silence does not mean disappearance. Long after Earth changes, long after human languages evolve or vanish, Voyager will still be there, drifting between stars, carrying proof that intelligence once emerged on a small world inside a protective bubble in a quiet corner of a violent galaxy. The impossible discovery Voyager made at the edge of the solar system isn't just about space, it's about perspective. We are not lost in the universe. We are sheltered within it. And for the first time in history, we know exactly how thin that shelter really is. If you want to keep exploring the mysteries Voyager uncovered and the discoveries still waiting beyond our cosmic doorstep, subscribe to our channel. Because the farther we look into the darkness, the more the universe seems to be looking back.